So today I will be covering parallel and perpendicular lines. 1 second. Where's my cursor? All right, so today going to be covering parallel and perpendicular lines, proofs, lines and angles and transversals, and then equations of parallel and perpendicular lines. All right, so first up, we have some properties of angle congruence, which just means angle equality. So first up, we have reflexive. Angle A is congruent to angle A. The symmetric property, which says that if angle A is congruent to angle B, then angle B is congruent to angle A. And then lastly, we have the transitive property, which states if angle A is congruent to angle B and angle B is congruent to angle C, then angle A is congruent to angle C. Next up, we have some congruent supplements theorem. First up, which is if angle 1 and angle 2 are supplementary, and angle 3 and angle 2 are supplementary, angle 3 and angle 1 and angle 3, are supplementary. So basically, what is it called? Let me write on the board real quick. Because supplementary means adding up to 180 degrees. So if angle, well, there we go. So if angle 1 and angle 2 equals 180, right? And then angle 3 plus angle 2, 80. And then angle 1 equals angle 3. Yep, that's just basically what it means simply. All right, there we go. And then the vertical angles congruence theorem, it just states that vertical angles are congruent. Vertical angles being like so. Like these two, this angle here and this angle here would be vertical angles, and these two vertical angles would be equal to one another. Give me 1 sec, my computer is a bit slow right now. Here's a practice problem. So last class, we were also working on geometric proofs. So what we have here is a given. So given B is the midpoint of segment AC, prove that AC is equal to 2AB, or AB is equal to 1/2 of AC. And then once you're done, you can just type your answer in the chat. Just make sure to include all steps of your geometric proof as well as the reasoning for each of them. And then we'll take about, let's take 5 minutes to work on this one. And then once you're done, I'll go over it. We'll just take another 2 or 3 minutes to wrap up this question. At the end of the 2 or 3 minutes, it's totally fine if you have not finished the entire problem. We'll just go over whatever you have gotten done. That's completely fine. All right, I'll go over the answer now. So first up, what we have is given that B is the midpoint of segment AC. So essentially what that tells us is that AB is congruent to BC, sorry. So then you would just show congruence through 2 lines or 1 line. So you would say AB, I can't write the fancy squiggly equal sign, but AB would be, and then that would be the definition of midpoint. Next up, you would have AB equals BC, which is the definition of congruent segments. I can't write it on here, I'll just draw it on. But for this one, it would be AB is congruent. This is a very important thing when you're doing geometry. The difference between if it's congruent or if it's equal. So the difference between, so for when you say they're equal, right, you're kind of saying it's numerical value. That way you can add segments. If you just say they're congruent, you cannot add them because they don't have a numerical value attached to them in a sense. And then you would say AC equals AB plus BC via the segment addition property. Then we would go into AC equals AB plus AB. This would be substitution, right? Because we already determined that AB is equal to BC, so we can just substitute that in. And then we can say AC equals 2AB by just saying simplify, right? And then we can just say, lastly, we can just say 1/2 of AC is equal to AB. You can just say division property plus like simplify. And then that would be your entire proof, going like this in order. And it's very important that you prove it in order that way, because you can only, this is kind of like building something step by step. You can't, jump steps in an instruction manual. Same thing with geometric proofs. You have to prove each step one by one. And I think the main point to highlight here is right here, these two, the definition of midpoint versus definition of congruent segments, what they determines, right? The definition of midpoint says that AB is congruent to BC, whereas definition of congruent segments say that if these two segments are congruent, then they are equal. So just keeping these two key differences in mind, and when you are doing proofs, you have to first say definition of midpoint and then definition of congruent segments. You can't just go straight into this because it only told you B is the midpoint. It never told you AB is equal to BC. And also, I forgot to add this on here, but for this one, it would be segment AB, segment BC, just adding the two little lines on top. Does anyone have any questions on this geometric proof and, like any part of it, how to solve it, anything like that? All right, I do not see any questions, so I will keep on going. All right, next up, we have some different definitions and just some different line types. So first off, we have parallel, which is marked by these two lines. It says that this tells you that line M is, these two double lines tell you that line M is parallel to line N. Intersecting, parallel is two lines that never meet. Intersecting is two lines that cross at one point. Coincident means that two lines that lie on top of each other. Skew means two lines that do not intersect and are not coplanar, meaning they're not on the same plane. And then perpendicular, two lines that form 490-degree angles, and you would write it as M, this upside down T, N. But really, the two main ones you should focus on are, are this one, the parallel lines, the intersecting lines, and the perpendicular lines, because these are the three main ones we're going to be working with. These two, the coincident and the skew, these are just to know as kind of background information. These aren't super vital when dealing with geometric proofs, and you won't really come across them. Oh, okay. What is the difference between intersecting and coincident? Let's just draw on the board right there. So intersecting means, let me draw it real quick. So this is what two intersecting lines would look like, right? So they would, they would meet at exactly this one point. Let's just call it point. Let's just call that point A, right? However, coincident lines, this isn't really kind of hard to draw, but let me second. So say this is I can't really draw the arrows right now, but let's just say this is segment AC, right? I'll write it down. So this is A, this is C on this end. And then we would have another line directly on top of it, like so. This isn't completely perfect, but you can see what I mean. And say this one would be segment like E, G, for example. That's the difference. So intersecting is they cross at one point. Coincident means that they cross at every single physical point possible on the line. Does that answer your question? Okay, great. Great. Okay. So now, so in this picture, which two lines are parallel? M and N are parallel, and parallel is marked by these two red arrows that you see. Whenever you see them, that just tells you that they are parallel. Which two lines are skew? K and M are skew because they never, these two lines never meet and they aren't on the same plane. Uh, Not exactly. When it's coincident, it's two different lines, I guess. They're different. It's hard. How do I explain this? So they're two exact, they're not the same line. They're different lines, but, and they're marked with different points, but they just lie on top of each other. But they aren't the same line, if that makes sense. They're two different lines. Yeah. But coincident isn't super important for you guys to know. That's more that's just kind of like background information that I wanted to give you guys. The main key three things you want to remember is intersecting, parallel, and perpendicular, and how to express the parallel and perpendicular. Remember, like we just said, parallel is marked by the two lines, and then perpendicular is marked by the upside down T. That way, when you're going like looking through problems, when you see that, you'll be able to exactly know, oh, parallel or perpendicular. Transversal is a line that intersects two or more coplanar lines at different points. So as you can see, it's intersecting them at two different places. Say this is just point B, and this is point H, right? So that would be what a transversal is. It's intersecting two lines at two different points. Next up, we have some types of angles. So what we have here for types of angles is corresponding angles, which is two angles that have corresponding positions. Alternate interior angles, two angles on opposite sides inside the two lines. Alternate exterior angles, which is two angles on opposite sides outside the two lines. Next up, we have consecutive interior angles, two angles on the same side inside two lines. And then, of course, the angles are all marked by the stars, so you know which ones we are talking about. Next up, give me 1 second. All right, now we have a quick little proof that I will walk through. So first we have, given a segment AX is congruent to segment, 1 second, it's the video monitors are blocking my screen. There we go. Given segment AX is congruent to segment DX and segment XB is congruent to segment XC, prove that a segment AC is congruent to segment BD. I'll go through this one. So first off, we want to list the givens, but first I'm gonna just mark these so I know, and then these two are congruent to one another, XB and XC. So first off, we want to always state our givens. That's the most important part. So we want to say segment AX is congruent to segment DX, and segment XB is congruent to segment XC. And that would be a given. Next up, we would have segment AX is equal to segment DX, and then segment XB is equal to segment XC, which is the definition of congruent segments. Next up, we would have AX plus XC equals AC through the segment addition. Next, we would have DX plus XC equals AC through substitution. Next, we would have DX plus BX equals AC through more substitution. Spelling is hard right now. Substitution. Next, AC equals BD through the transitive property. And lastly, we would have AC is congruent to BD through segment congruence. Yes. Does anyone have any questions on this while I get my... Oh. Yeah. Does anyone have any questions on why do you need transitive and segment addition? Why do you need transitive and? So segment could be. Oh, sorry, because it's hard to write on my trackpad right now. That's why I'm currently trying to join the Zoom meeting with my iPad in one moment. So why do you need transitive property? Let me just quickly draw it. So for this, right, for the first, after the transitive property, it would just be AC equals BD. But because we're trying to prove congruence, right, not equals. So we have to say segment congruence. Then we can say segment. Sorry, I just forgot to draw it because it was on the trackpad. But there is a difference between these two. There's a difference between saying AC is equal. Then there's a difference between saying segment AC is congruent to segment BD and saying AC is equal to BD. Does that make sense? One second give me 1 second, guys, while I just join with my iPad as well. That way I can annotate on the board much easier. All right, there we go. So does that answer your question, Jake? Okay, great. Does anyone have any other questions on this problem? All right, I will keep moving along. Give me 1 second to clear. All right. Next up, we have some more definitions because geometry is just all about definitions. So the definition of linear pair versus linear pair postulate, kind of what I just talked about like segment congruence versus, segment equality. So definition of linear pair tells us how to identify a linear pair, whereas the linear pair postulate tells us the angles in a linear pair are supplementary or equal to 180. So for example, right, in this one, you see that angle ABC and angle DCB, ABC and angle CB. Oh, sorry, that's a typo on my part. This should say ABD right here, not C. ABD and DBC are a linear pair, and this would be given. But then you also have to say angle ABD and angle DBC are supplementary through the linear pair postulate. That way you can do other fun stuff with it, like angle ABD plus angle DBC equals like 180 degrees through, definition of linear pairs, that kind of thing. Because you can't just go straight from they're a linear pair to they add up to 180. You have to have that step in the middle. I know it's very tedious and it's finicky, but that's just what geometric proofs want you to do. Does anyone have any questions on definition of linear pair postulate, or like why we do this? All right. Next up, this is just kind of reiterating what we just talked about a few slides before. M and N are parallel and L is a transversal. Next up, we have these two problems. So now that you know that from this diagram, you can see that A and B are parallel, and then in this one, C and D are parallel. Let's just take a few minutes to quickly solve for what X equals and what Y equals. Oh yeah, and then once you're done and you found the answer, you can just put your answer into the chat box and I'll take a look at it. All right, let's just take another 2 minutes to wrap up these two questions, and then once you're done, just put your answers in the chat box. All right, I'll go over the answers now. So for the first one, we would first set it up as 2x plus 120 80. And then from this, we would solve it just regularly like an algebraic equation where 2x equals 60, x equals 30 degrees. And then for this one, we would say 6y minus 3, give me 1 second, equals 129. 6y equals 132, and y would equal 22. I'll get into like in another like slide or two, we'll get into like why this is so, but just this is just kind of previewing to you guys what we will be doing in a sec with parallel lines. All right, now going on to different kinds of parallel lines. So first, if parallel lines cut by a transversal, corresponding angles are congruent. If parallel lines cut by a transversal and alternate interior angles are congruent. If parallel lines cut by a transversal, alternate exterior angles are congruent. And lastly, if parallel lines cut by a transversal, consecutive interior angles are supplementary. These are the four main ones you should know, and all the stars just mark where what the two angles are that they are talking about. Does anyone have any questions on any of these? All right, great. And then we have, with any of these, we have the converses. So the corresponding angles converse. If two lines are cut by a transversal so that corresponding angles are congruent, then the lines are parallel. If two lines cut by a transversal so that alternate interior angles are congruent, then lines are parallel. If two lines are cut by a transversal so alternate exterior angles are congruent, then the lines are parallel. And lastly, if two lines are cut by a transversal so that consecutive interior angles are supplementary, then the lines are parallel. A transversal, like that was mentioned in the previous few slides, it's just a fancy term for a line that crosses two or more other lines at one point. That's basically what a transversal is. I know geometry likes to call, these things, these like different kinds of lines, very fancy names, and it's kind of hard to keep track of, but it'll come with time and practice. And then the transitive property of parallel lines. So if line L and M are parallel and line M and N are parallel, then line L and line N are parallel. If two lines are parallel to the same line, then they are parallel to one another. Next up, we have ratios. So BC over AB is equal to DE over AD, and then FG is over AF is equal to that. And then we'll get into this very soon. This has to do with cosine, sine, and tangent. But this is just something about ratios that I am previewing right now. Next up, a ratio for a 30, 60, 90 right triangle. This is pretty important. You'll throughout math, you'll always see the 30, 60, 90 triangle. You can never escape from it. And then you should know the ratios. You should remember the ratio. So the hypotenuse will always be 2x. The base, or the side opposite to the 30-degree angle, will always be x, and the side opposite to the 60-degree angle will always be x or 3. So say you know that this leg, right, this one right here, was 4, then the hypotenuse would be 8, and the leg would be 4 root 3. You can also prove this through the Pythagorean theorem, where it says a squared plus b squared equals c squared, where if you have 16 plus 16 times 3, because 4 root 3 is 16 times 3, equals 64, because this is 48 and this is 16. So checks out with the Pythagorean theorem. And then, so for any 30, 60, 90 triangle, assume that angle A is equal to 30 degrees. Then the length of the leg opposite angle A divided by the length of the hypotenuse equals 1/2. And then which gets us sine 30 equals 1/2. Does anyone have any questions on any of this that we just covered? All right. Next up, we have the three trigonometry ratios. We have sine, cosine, and tangent. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Basically, what this means is that for any, that's a bad color, 1 second. Oh, no. Give me 1 second. It means that for any triangle, right, we have here, and remember for this, it should always be a right angle triangle. So for this one, so say this is x, right? This little angle right here is x. Sine would mean the ratio of the opposite side, this side right here, over the hypotenuse. Cosine would mean the this side, the adjacent side, over the hypotenuse, and tangent would mean this side, the opposite side, over the adjacent side. So now let's really quickly work on these two problems where you guys tell me what the let's for this one, let's say this angle, right? Tell me what the sine, cosine, and tangent of this angle are equal to. And then once you're done, just put your answers in the chat box. Okay. And then the question is just, can you guys find the sine, cosine, and tangent values of the angle X right here in the first triangle in this first picture, in the first picture? All right, we'll just take another 2 minutes and then I'll go over this question. All right, I will go over the answers now. So for triangle number one, sine would equal 8/17. Cosine would equal 15/17. And tangent would equal 8/15. So for this triangle, right? Um, remember again what sine essentially means for now. What we need to know is that it just means the ratio or what the opposite side of the angle, which is 8, divided by the hypotenuse, which is 17. Cosine is the value of the adjacent side divided by the hypotenuse right here. And lastly, tangent is the value of the opposite side divided by the adjacent side. And then for this last one, I will just quickly go over it as well. So for this one, let me, okay, there we go. For this one, you can just use x as a placeholder. So you would have, 1 second, my computer's kind of freezing right now on me. 1 second. Yes, so for this one right now, you can use for this case, you would have to use a calculator to find the value of this because it'd be impossible to solve the value of tangent 32 using by hand. For this one, essentially, right, we are given the angle, we are given the side, but we need to find the other side. In this case, right, we would just use one of these ratios. And then, of course, we would use tangent because you have the opposite side and you have the adjacent side. And we're trying to find the adjacent side. So we would have tangent of 32 degrees is equal to 11 over x, where then you would multiply the x over, right? And then where you would then get x times tangent 32 equals 11, right? And then you would, of course, move the tangent over to the other side, getting your final equation to x equals tangent 11. Sorry, guys. 11 over tangent 32 degrees. And then this would be the point where you would just solve it with your calculator because you can't physically solve this by hand. And then in this case, you would get x equals about 17.6. And then that is how you would use it. You would use the trigonometry ratios in the opposite fashion, where as in the first part, you were using it to find the angle. In this part, you have an angle, you have a side, and you're trying to find the unknown side. Whereas the first one was you have the angle, you have the sides, sorry, you have all the sides, and you're trying to find the angle. Does anyone have any questions on any of these? All right.